Hello, we're back with another, I'm back with another video, and I'm going to be doing October-November 2024 paper 12 this time. Let's get into it. The first thing we got to do is put our name down over here. So I'm just going to put my name down over here, and let's start. The first question is about trigonometry. We have a sine wave. It says the diagram shows the curve with the equation y equals a sine bx plus c for some values of x that are given to you from 0 all the way to 2 pi, where a, b, c are positive constants. Find the value of a, b, and c. So this guy's a, this guy's b, this guy's c. Let me just tell you guys what these mean. So if you see y equals to a times some trig ratio, and this trig ratio could be a cosine, sine, or a tangent, and then you see a bx plus c, basically what that means is this thing represents a transformation, so does this, and so does this. So the c term basically represents how up or down you go, how up or down those points have went. Or in other words, you have a baseline. So for example, if you have a sine wave, a normal sine wave like this is the y-axis, this is the x-axis. So this would start at y equals 0, or at the x-axis, right? So baseline basically means, does your sine wave start over here? Or for example, let's say you have a different sine wave that's right over here. So it would start over here. This would be its baseline. But for the basic version, this x-axis is the baseline. So this plus c basically represents that baseline. Now in our case, you can see the baseline is actually over here. So the entire sine wave has shifted up by how many units? So it was on 0, now it's at 3, that means it's shifted up by 3 units. So basically c is going to be 3. What about b? B is the frequency, okay? So b is the frequency. It tells you, so if a basic sine wave, let me draw this over here. This gets completed in 2 pi, okay? This gets completed in 2 pi or 360 degrees. Now, about this particular sine wave that we're seeing over here. So how many complete sine waves do we get in this 2 pi? That's basically what a frequency means. A frequency means how many complete trig waves you're getting within 360 degrees or 2 pi, or in other words, one cycle. If you check it out over here, I can basically show you guys that this right over here would be one complete sine wave, and then this next part, this part would be the second complete sine wave. So we have two complete sine wave in one cycle, or in 2 pi. Therefore, that means the frequency is basically 2. Again, what does the frequency mean? It means how many complete waves are being formed in 2 pi or 360 degrees. What about this a? What does this a mean? This a means the amplitude. Now, they could have a different letter over here instead of a. They could have an x, they could have a t, they could have a g. Point is, if it's being multiplied to the trig ratio, it represents the amplitude, or the maximum most point or the minimum most point that you're away from the baseline. So this right here is my baseline. How up do I go? So I go 1 unit up, 2 unit up, 3 unit up, and 4 units up. That's my maximum point. And then the same goes for when you're going down. So you're going 1 unit down, 2 unit down, 3 unit down, 4 units down. So your baseline, or your maximum distance that you have, or sorry, your amplitude, or in other words, the maximum distance that you have from the baseline is of 4 units. You're going a maximum of up by 4, and you're going a maximum down by 4. So a is going to be equal to 4. So a is 4, b is 2, c is 3. That's what we have over here. Okay, let's clean this. So moving on to part B, what do we have for part B? Part B says for each values of a, b, and c, for these, sorry, not for each, for these values, which means that basically this is the graph we're talking about, where a is 4, b is 2, c is 3. Or in other words, this is the graph that we're talking about. This is the sine wave that we're talking about. So they're basically saying for this particular sine wave, determine the number of solutions in the interval. So that's, again, the same range that they give you for the x values from 0 to 2 pi for each of the following equations. So we have to find out the number of solutions, not the value of solutions, for two equations. So the first one is this one, the second one is this one. Now, how do you do this problem? You basically try and understand it like this. You split this part and this part into two different equations. So you basically look at as if this was y equals a sine b of x plus c, and another equation y equals 7 minus x. And so if you combine both of these equations, if you say y equals y, then you basically have a sine bx plus c, and then this is equal to 7 minus x. So you have two equations, you're combining those two equations, and basically what you're trying to ask over here is how many intersection points am I going to have between both of these equations, or both of the graphs of these equations. So you're trying to find the number of solutions, the number of intersection points, not the coordinates of those intersection points. And then you do the same over here for the second part, but let's do it for the first part. So what's going to be the graph for this guy? The graph for this guy has already been made out for you. This is the graph of y equals a sine bx plus c. So then our question is, what's going to be the graph of this guy? Well, it's y equals 7 minus x. We know this is a line equation. A line equation. If I rearrange this, it's going to look something like y equals negative x positive 7, which is in the form y equals mx plus c. Okay, so let's plot this function out over here. So the equation is y equals minus x plus 7. So first, let's try and find out what's going to be at, and I'm going to use a different color. Okay, I'm going to use blue for this. What is the value for y when x is equal to 0? So the value of y is just going to be 7. So we have one point at x0, y7. That's going to be right over here. Boom. What else? What else? We found out where it sort of is going to be at what's going to be the y-intercept value. We can go ahead and find the x-intercept value real quick. And so this is going to be y equals negative x positive, or actually, I don't think that I will be able to. Hold on. What's 2 times pi? 2 times pi is equal to 6.2837. Yeah, I don't think I will be able to find because my x-intercept value is going to be way too big for this particular region, right? 2 pi is 6.8 something, and I believe that for the x-intercept value, I'm going to get 7, and I can't put 7 on this graph. So let's just use some other value. Let's try and find out what y is when x is equal to pi. Yes, that's something we can do. What is y when x is equal to pi? Pi plus 7. So y is going to be, what is minus, what is minus pi plus 7? That is equal to 3.858. Okay, so this is equal to 3.858. So where can I get 3.858? Let's try and figure that out. What is pi, right? Pi is 3.142. Pi is 3.142, right? So what is 3 divided by 2 times pi? What is this equal to? This equals to 4.71. That means that the value is going to be somewhere over oh wait, that's the y-axis. Sorry, my bad. 3.858. So that's this is x equals pi, and then y has to be 3.858. That's going to be somewhere over here. So somewhere over here. Right there. Okay, that's good enough. Now, you don't need exact values. You just need to approximate this. This is going to work even if you approximate, so you don't have to worry about anything. I guess 2 points are enough. You could, if you want more points, you could go for more points. For example, I can just go and find out what is y when x is equal to negative, when x is equal to negative 2 pi. Okay, so when x is equal to negative 2 pi plus 7, this is equal to 0.7168. Okay, so it's going to be somewhere, this is 2 pi, x is 2 pi, and then y is 0.716. I believe that's going to be somewhere over here. And this is 2 pi, so somewhere over here. Right over there. Now, again, we just need a rough idea of what's going on. You don't need to have exact values for problems like these. This is also a recurring problem. You will see this question where you have to find solutions in many sort of past papers, and all you have to do is you just have to get approximate values. So if I now roughly join the lines, it's going to look something like this. And how many intersection points do I get? So I get 1, 2, 3, 4, 5. That means I have, how many solutions do I have? I have 5 solutions or 5 intersection points. Now we're going to do the same for part number 2. And again, we have this graph. It's already been plotted out for us. This is what we need to plot out. You could sort of simplify this if you want to, but you don't have to. You can use it like this. Now, I don't know what this graph is going to look like. Actually, I do know what it's going to look like if I expand this out. So let me just expand this out. So this is going to be 2 pi x minus 2 pi, which means this, if I write this as y equals this thing, so this is going to be a constant, right? Because 2 pi isn't going to change its value. So it's going to be the c term, and then this is m, this is x, and then this could be minus. So it's y in the form y equals mx minus c, which means this right over here is also a line. It's also a line graph. Therefore, what we can do is we can sort of first find out the intercept value maybe. So we can find out the y-intercept. So we could do y equals 2 pi, put x 0, and then minus 2 pi. So y is going to be equal to minus 2 pi. Oh, we don't have that value. Minus 2 pi is going to be negative 6 point something something, and we don't have negative 6 point something something over here. Okay, so we cannot choose that value. That means we have to choose a different value. How about I choose 1 by 2 pi. Okay, that's a good value. Let's choose 1 by 2 pi. So I'm going to choose x is equal to 1 by 2 pi. So that's going to be 1 by 2 pi. The 2 cancels out the 2. And so I get y equals pi squared minus 2 pi. How much is that? Pi squared. Pi squared minus 2 pi. That is equal to 3.586, right? So 3.586, that's going to be somewhere over here. And this is 1 by 2 pi. So I believe my intersection point is going to be somewhere over here. Okay, perfect. What else? Let's take another point. Let's take the point pi, I guess. We can take the point pi. Take the point pi. And so what we can do is we can basically get y equals 2 pi times another pi times minus 2 pi. So this is going to be minus y equals 2 pi pi is going to be 2 pi squared minus 2 pi. And if I solve this out on the calculator, this is 2 pi squared minus 2 pi. What is this equal to? 13.45. I'm also not going to get this value on the graph because the maximum I can get is y equals 8. Okay, this is getting tricky. Which something can I choose? What can I choose right now? Okay. How about I choose this value over here? So, uh, what's that value going to be? So if this and this is equal to half a pi, because see, 1 by 2 pi, and then we go over here, that's 1 half, that's 1 half. This is difficult. This is not easy. Okay, here's my idea. Here's my idea what I'm going to do. So I'm going to find out how much this one block is equal to. And one way I can do that is I know that pi is equal to how many blocks? 1 block, 2 block, 3 block, 4 blocks. So I can divide pi by 4, and that would basically give me pi by 4. So that basically means that 1 block is equal to pi by 4, which means that this is going to be from 0 to pi by 4. Over here, on this first block, my x is going to be pi by 4. Pi by 4. Okay, so let's try and find out what my y is going to be at this value. So it's going to be 2 pi times pi by 4 minus 2 pi. Let's solve this out. 2 pi times pi by 4 minus 2 pi. So this is equal to negative 1.34, negative 1.348. Now I also don't have this on the graph, but let's say I extend this just a little bit. This becomes negative 2, and negative 1.38348 is going to be somewhere over here, okay? So right over here is where I'm going to have my value. And so I can sort of join these 2 points like this. I don't need a third point. I can just join these 2 points like this. And I can clearly see that I'm only going to have one intersection point, one solution right over here. So for part 2, I'm going to have one particular solution over here. Now, question 2 is an arithmetic progression problem, which tells us that the first term of the arithmetic progression is a, and the common difference d is 5. So part A says, find the sum of the first 20 terms of the progression, which is a fairly easy problem. So the sum of the n terms is given by the formula n by 2 times 2a plus n minus 1 times d. Therefore, this is going to be n terms if we're trying to find out for the first 20 terms. It's going to be 20n divided by 2, so that's 10, times 2a, so a is negative 20, put that in here, plus n minus 1, 20 minus 1 is 19, 19 times 5, 19 times 5, and we have to now solve this. So we can basically use our calculator again, 2 times negative 20 plus 19 times 5, and this is equal to 550. So the first 20 terms have a sum of 550. The next part says it is given that the sum of the first 2k terms is 10 times greater than the sum of the first k terms. What does this mean? We have to find the value of k. Before you look at this part, let's try and understand what all of this information even says. So we know that Sn is equal to n over 2 times 2a plus n minus 1 d. Now there are two sort of sums that are given over here to us. The first sum is of the first 2k terms, and then the second sum is of the first k terms. Therefore, the two sums are, so sk is going to be k by 2 times 2 times a, so a is negative 20. I'm just going to write negative 40 over here. Negative 40. Negative 40 plus n minus 1. N minus 1 is going to be k minus 1 times 5. So this is the sum of the first k terms. Now, there's another sum that is of the first two k terms, and that's going to be 2k over 2. So that's just going to be k, because 2k divided by 2 is just going to be k. Again, times negative 40 plus 2k minus 1. 2k minus 1 times 5. Okay, so these are the two sums they are talking about. And then they tell you that there's a relationship between these two terms. Here's the relationship. So they say the sum of the first two k terms, so the sum of this guy is basically 10 times greater than the sum of the first k terms. So this s2k is basically 10 times greater than sk. So basically, in other words, they just give you an equation which is s2k is equal to 10 times sk. Now see, I'm not even solving the problem right now. I'm just trying to digest the problem, and that's so important. That's what I say in all of my videos is basically just take the information, work with it, and then you'll realize that the answer is, you don't actually have to work for the answer. You just have to work to make sense of the information that's given to you, and then the answer just becomes obvious. So this right here, these are basically the three equations that they give me in this one sentence. So that's how much information that sentence loads into it. Now, we have to find the value of k. That's going to be really simple. So you have this equation, you know what sk is equal to, you know what s2k is equal to, therefore just put them in this equation and you're going to solve for k. So s2k is basically k minus 40. So well, what's k minus 40? Do I want to simplify it right now, or let's just write it the way it is and then we'll simplify it later. So s2k is k times negative 40 plus 2k minus 1 times 5, bracket closed, is equal to 10 times s of k. So 10 times s of k. K is k by s of k is k by 2 times negative 40 plus k minus 1 times 5. All of this. Okay, this is your equation, and now you just have to make k the subject and solve for k. I still hate the fact that this problem has is just of 3 marks. I feel like there's going to be a lot of working that I'm going to have to do. Okay, anyways, here's what I can do. I can sort of, so here's what I can do. So k times negative 40, I'm still not going to expand it because I realize I can do something over here. Times 5 bracket equals, I can simplify this. 2 times 1 is 2, 2 times 5 is 10, so it's going to be 5k times negative 40 plus k minus 1 times 5. Here's what I can do. Do you see a k over here, and do you see a k over here? So basically, you can take a k from one side, take it to the other side, divide it with the other k, and it's going to cancel out. So imagine I've just done that, and now these k's go poof. These k's go poof. Now, what would happen if I didn't do that? So see, if you hadn't done that, this k would go in this bracket, multiply with this k, give you a k squared. Then this k would do the same thing, go inside this bracket, give you a k squared, and now you have to solve a quadratic equation. And I don't think that it's worth 3 marks for doing that much working. So I just looked at the marks, and I realized, come on, it cannot make me do that much work. So first I sort of create these 3 equations, then I sort of input them, then I do a whole bunch of algebra, then I solve a quadratic equation. So I realized over here that it can actually be simplified to a linear equation. And now there is no k to multiply and turn the inside k's into k squared, so the problem is very much simpler. Okay, so let's expand this now. So negative 40 plus 5 times 2 is 10k, 5 times 1 is negative 5, is equal to, let's do the same over here. So 5 bracket negative 40 plus 5k minus 5. On the left hand side, we're going to get negative 5, negative 10, sorry, negative 40. That's going to be 10k negative 45 is equal to, over here we got 5 bracket, we got negative 40, negative 5. That's also going to be negative 45. And now we can sort of multiply that 5 inside the bracket. So we're going to get 5 times 5 is 25k minus, what's 45 times 5? 45 times 5, that's equal to 225. 225. Okay, let's take the k terms to one side and the constant terms to the other side. So we're going to get 225 minus 45 equals 25k minus 10k. So 225 minus 45, that's equal to 180, is equal to 25 minus 10. What's that equal to? 25 minus 10. 15k. So k is going to be 180 divided by 15 divided by 15. And the answer of k is going to be 12. So there you have it. We're on question number 3 right now, and it says the equation of a curve is y equals 2x squared minus 3. 2 points, A and B, with x coordinates 2 and 2 plus h respectively, lie on the curve. So basically, they give us this curve. It's a parabola because it has x squared. And then there are 2 points, A and B. A has the x coordinate 2, and B has the x coordinate 2 plus h. Nothing too fancy over there. Part A says, find and simplify an expression for the gradient of the chord AB in terms of h. What does that mean? So you basically have a parabola over here, right? Now this parabola will basically, let's say, you get something like this. And then it has points, 2 points, let's say A and B. Or A and B could be at other different directions. Just for reference, I'm using these 2 points. You can choose any 2 random points as A and B. So this is A, this is B. There's a chord that passes through A and B. A line. A chord is basically a line. Now imagine this is a perfectly straight line. Now we have to find the gradient of this line. So how can we find the gradient? So the value or the equation for gradient is basically y2 minus y1 over x2 minus x1. Do we know y2? No, we don't. We don't know what the y value of B point is, and we don't know what the y value of A point is. So let's first find those. So for A, let's first do that. If we have y equals 2, what's the x coordinate of A point? It's 2. So I get this particular thing, and when I solve it out, 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5. So the points of A are 2, 5. Now let's do the same for B. So for B, we're going to have y equals 2. Instead of x, we're going to put 2 plus h, because that's the x coordinate of B. Square this, minus 3. And then we're going to get the identity applied over here. So it's a plus b whole squared, which is a squared, 4, plus 2ab, which means 4h, and plus b squared, which is h squared, minus 3. We can multiply this 2 inside the brackets. So 2 times 4 is 8, and then 2 times 4 is 8, and then 2 times h squared is 2h squared, minus 3. So this minus 3 and this 8, they're going to sort of subtract each other. And I'm going to rearrange this. I'm going to get 2h squared plus 8h plus 5. So 8 minus 3 is going to give me 5. So this is what I have as my y value for point B. Now, what I can do is I can basically put it in the gradient. So that's going to be 2h squared plus 8h plus 5 minus y1. y1 is 5 over the x squared, which is 2 plus h, minus the x term, which is 2. So this and this cancels out. This 2 and this 2 cancels out. So I get 2h squared plus 8h over h. Now, remember, the question says simplify an expression for the gradient. So I can still simplify this further. There is something I can do over here. And what that is I'm basically going to take this on this side. I can factor out an h in the denominator. So in both terms, I can factor out an h as well as a 2. So let's do that. Let's factor out a 2 as well as an h. So I get h plus 4 over h. Okay? Yeah, I believe that's correct. And you can still simplify this. If you notice, this h cancels out with this h. So therefore, you're going to be left with 2 times h plus 4. This is the simplified version of the expression of the gradient that we're going to get. Now, part B says, explain how the gradient of the curve at point A can be deduced from your answer to part A and state the value of this gradient. So you basically have to explain how you can get the gradient of the curve at point A. Now, here's the idea. Initially, I drew something like this. So I had 2 points, A and point B, right? And I said there's a chord that's passing through them. And I said that the gradient is basically y2 minus y1 over x2 minus x1. Now, here's the idea. If I move this point, if I move this B point, so this is B, this is A. If I move this B point over here, what's going to happen? The new chord is going to look like this, right? And then let me choose a different color. What happens if I move this B point further? So now the chord is going to look something like this. This is the new B point. What happens if I move it even more closer? So close that it's almost on top of A. It's not exactly on A, but it's almost on top of A. Then the chord is basically going to be the tangent line at point A. So this chord is basically going to become the tangent line at point A. Tangent line at point A. Point A. So basically, what am I doing? I'm basically moving that B point closer and closer and closer and closer and closer and closer to A until it's so close to A that when I sort of draw a chord between them, that chord is almost, you can put the word almost the tangent line at point A. So basically what I'm saying is I'm saying that, hey, if I have this curve and if I have this curve, A and B are so close to each other that when I draw a chord through them, it looks like this. And that's exactly what the tangent line of A looks like. Now, of course, this is more exaggerated. They're still far away. I want them to be so close to each other that you cannot tell if they are two different points or one single point. That's how close you want them to be. And so what happens, something crazy happens, is that the chord of AB becomes the tangent line of point A. Now, the same could happen if you kept B point at its position and moved A closer and closer and closer and closer and closer to B. Then the chord of AB would basically become the tangent line of point B. So how do you do that? How do you find that out? So the entire trick in moving the point B closer to point A lies in this coordinate, this x coordinate over here. Why? Because it's 2 plus h. And what's the coordinate of A? The coordinate of A is 2, right? So it's the coordinate of A is equal to 2 and the coordinate of B is equal to 2 plus h. You don't have to worry about their y coordinates. The reason is because see the y coordinates, the y depends on x, depends on x. Basically, this right over here, the equation, it's y in terms of x. So you don't have to worry about, oh, what about y? I'm not doing anything to y. I'm just thinking about x. You only have to think about x because if x changes, y is automatically going to change. So if the x coordinate of b is super close to the x coordinate of a, then the y coordinate of b will also be super close to the y coordinate of a. So over here, what I'm really doing is see there are 2 points, A and B, and they what are they separated by? This has a 2, this has a 2. The only difference is you're adding some value h into that B coordinate that makes it sort of go away from the A coordinate. So if you put a tiny value in here, let's say you put in 0.1, it's going to be super close to A. If you put in 10 over here, it's going to get really far from A. If you put 1000 in here or 100 in here, it's going to get really, really, really far. But if you put a really, really, really tiny value, like let's say 0.00000000001, this B coordinate would almost be the same as the A coordinate. It's almost going to be 2, right? 2 is almost equal to 2.00000000001. Okay, so they're almost equal to each other. Therefore, the idea is reducing this h value. If you reduce this h value, you reduce it, it's going to basically jump. This B point is basically going to jump on point A, and the chord of AB is going to become the tangent of A. Now, they say state the value of this gradient. So we know what we're doing. We're sort of reducing that h value all the way to 0. But this is the x coordinate. We're doing something to the x coordinate. So the x coordinate becomes, it goes from being 2 plus h to almost 2, right? But they're not interested in the x coordinate. They're interested in the gradient. So how do we find the gradient? Well, lucky for us, that's why they make us use the part A simplification, because we already have a simplified equation for the gradient in part A that we found out. So the gradient is equal to the simplified expression. And so therefore, if we have gradient as 2 times h plus 4, we know what we're doing is we're really making it really close to 0. And another way of saying this is basically you're not doing anything to h, right? If you're not, it's so see 100 is small, then 10 is smaller, then 1 is smaller, then 0.0000001 is smaller. What's the idea over here? What are we really doing over here? We're making the h value really small. So how you basically solve this is you just say h is basically 0. It's really close to 0, so it's almost 0, and therefore the value is going to be just simply 2 times. So 0 plus 4 is 4, so it's going to be 2 times 4, which is just going to be 8. Or if you want, you can put a really tiny value in here. Let's say you can put h as 0.0000000000001 plus 4, and then again, the answer is going to be 4.000000000, right? This many 2, so this, sorry, 8 point this much, and this is almost equal to 8. So you can do either of these things, right? It completely depends on you. Okay, so we're on question number 4, and it's a binomial expansion problem. So we have to find the independent of x term in the following expressions, and we have 2 expressions over here. This is the first one, this is the second one. So what we have to do is we need to have a term that doesn't include an x variable. So let's first do it for this particular part over here. Now, there are 2 things you can do. You can either sort of just write down all of the binomial expansions all the way to the power 6, and then eventually you'll find out one that doesn't include the independent term, or that doesn't include the x variable. That's one thing you can do. The other thing you can do is you can try and think about, what combination or sort of what power can I use such that my answer is going to be independent of x. So the first situation is obviously the first thing you can do is really easy. You're going to do n choose r, and then you're going to do a n minus r b raised to the power r, and you're going to try all possible combinations. You're going to make this r go from 0 all the way to 6, write down all the possible values, pick out the one that's independent of x. That's the easy way. Here's how you can do it faster. It's a bit difficult, but it's going to save you a bunch of time if you can figure out what to do. So the a term and the b term are going to multiply. Okay, so the n choose r multiplies with the a multiplies with the b. What's the a term? The a term is an x. What's the b term? The b term has an x in the denominator, and not just an x, but an x squared. Therefore, you somehow need this thing to have the same power as this thing, such that when they multiply, they cancel each other out. Now, you also have to be careful about the relationship between these two guys. So this denominator is two times greater than that numerator. Therefore, what do we have to do? We have to make sure that the power that we multiply x with is 4 times greater than this guy. Why? Because see, if let's say I multiply this with 2, what's this going to become? This is going to become x to the power 4. But over here, how much will I multiply? Will I have to multiply this number with to turn it into x to the power 4? I'll have to multiply it or raise it rather to the power of 4. Okay, multiply its power. Right now its power is 1. I'll have to multiply that power with 4. So what I'm doing is I have to be mindful about the relationship that exists between them. Is that the denominator of the b term, this guy is 2 times greater than that of the a term. And therefore, the a term needs to be sort of multiplied with a higher power than the b term. So how do I do this? Again, this is the relationship I mentioned, right? If I'm raising the b term by 2, I have to raise the a term by 4. Therefore, here's the idea. If I do NCR, okay, and I choose n to be 6, n is my total number of powers that I have, the maximum number of powers that I have is 6, I'm going to choose how many powers? I'm going to choose 4 powers out of them. Sorry, 2 powers out of them. 2. And why 2? It's going to make second in just a bit. It's going to make sense in just a bit. So this is going to be my n choose r, and then I multiply it with the a term. A term is going to be x. It's going to be raised to the power 6 minus 2. And then for the b term, I have 3 divided by x squared. This is going to be raised to the power r. R is 2. And so check this out. This right here is going to become 4. So x is raised to the power 4, while b is raised to the power of 2. Why? Because let me simplify this. So what is 6 choose 2? 6 choose 2 is basically equal to 15. This part is 15. And then I times it by x raised to the power 4 times. So 3 times 3 is going to be 9. And then x squared raised to a power of 2, that's going to be x to the power of 4. Okay, and so check this out. Now this cancels out really easily. Boom, boom. So all I had to do was I had to sort of understand that first of all the a and b cancel each other out, and then I had to understand the relationship between their powers. Once I understood that, the rest was fairly simple. Choosing the r was fairly simple. So 15 times 9, that's going to be 135. That's the term that is independent of r. Sorry, that is independent of x. Now part b. Again, we're going to do the same thing in part B. Now, you can do 2 things. You can either expand all of this, and then multiply all of those terms with this bracket over here, and then try and see which term ends up having no x, or here's what you can do. So you can do, you can sort of see that this guy right over here has a power of x to the power 3. If you multiply it, if you get from over here, you get, let's say, a oh, okay, this one's going to be a bit tricky. So you can do it in 2 ways. So first of all, try and understand this. You can basically take this term 4x3 minus 5 and start multiplying it with the expansion, all of the expansions that you're going to get from this part. And then what you're going to get is you're going to get some terms that are not going to have x, and then you're going to get some terms that do have an x. And what you want is you want to pick out those constant terms and you want to solve them out. On the contrary, there's another thing you can do. So what that is basically, see, this first bracket has 4x cubed and negative 5. Now the expansion of this second bracket is going to give you different things. It's going to give you a term that is independent of x, a term that has 1x, then x squared, x cubed, x4, x5, all the way to x6. You want, what do you want to multiply this number or this thing with? You want to multiply, so this negative 5 does not have an x term. Therefore, if you want to end up with an answer that does not have an x term, you need to multiply it. You need to multiply this with a constant from the second bracket, What do I mean by that? So basically you got this bracket, you're going to expand it out, right? And you're going to expand it out. There's one term that you're going to get, 135. It doesn't have an x. if you multiply this -5 with that 135, you're going to end up with a term that doesn't have an x. Okay, and see, you're trying to be independent of x. You don't want x. Therefore, if you multiply this -5 with that constant number 135, you're going to have a number that's a constant number that doesn't have an x. What about this 4 by 3? What do you multiply this guy with? So you expand this bracket again. You sort of start expanding it, and then you're going to get a term that is going to have x to the power 3 in the denominator. What that's going to do is you multiply this with this x3 and this x3 cancel out. So the first part is actually easy. That's basically finding out one of those independent terms is this simply this -5 times that 135. So times -5. This is the easy part. One of the answers is going to be -675. This is the easy part. Independent of x doesn't have an x. However, again, if you multiply this -5 with any other expansion than this 135, that expansion is going to have an x term in it, and that's going to end up in you having an answer that has an x term. So you don't want to do that. Now, let's try and figure out how do we expand this second bracket, such that we get a term that has x to the power 3 in the denominator. Okay, so the bracket it's something like this. It's x plus 3 over x squared raised to the power 6. These two terms are going to cancel each other out because the a term is multiplied with the b term when we're doing the binomial expansion. So these two terms are going to try and cancel each other out. Therefore, here's the idea. You want some number to be here such that when it cancels out, you get an x cubed. So let's try and think about all the numbers we can get, right? What if, so the maximum possible sort of power you can have for this right side is this power of 6. You can raise this b term to the power of 6. And in that case, 6 times, what is this power going to be? This power is going to become 12. 2 times 6 is going to give you 12. We don't want 12 right now because then you would have 6 over here, right? And then if you have 6 and 12 and you cancel them out, you don't get x raised to the power 3. So you're trying to get a different number. You're trying to think of a different number. And what if you have a 6 over here and you have a 3 over here? If you subtract these two numbers out, then you do get x to the power 3. So the question is, how do and is this something we can get? Is this combination something we can get? Well, yes, it is. Why? Because see, the relationship is maintained. This denominator is 2 times of that a term. However, so some of you may be like, well, why didn't you instead go with the term? Let's say this guy has x to the power 8 and this is x to the power 5. So you guys can go like, well, you can possibly go have a combination like this. Why didn't you choose that one? Thing is, I can't have this combination. The reason is because this relationship is not maintained. They were supposed to have a multiplied by 2 relationship. Now they don't. 8 is not, you don't multiply 8 with 2. Sorry, you don't multiply 5 with the 2 to get 8. So that initial relationship that we had, we need to somehow maintain that relationship. Therefore, what we can do, I'm going to change my pen color over here. What we can do is we basically now know that this thing has to be 3, this thing has to be 6. So this what is this? This is the b term, right? What power is b raised to? So b is raised to the power r. Therefore, if you already have an x squared in the denominator and you want and you're trying to figure out what this r is going to be, then just try to think about what do I multiply 2 with so that I get 6. Okay? And you multiply 2 with 3 so that you get 6. Okay? Or if rather you can try and think about it like this. This is a raised to the power n minus r. N is 6. So try and think about, okay, what number do I sort of subtract from 6 so that I'm left with a power of 3? Well, that's 3. And so your r is going to be equal to 3. And so what I can do over here is I can basically do 6 choose 3 and then times a, which is x raised to the power 3, because 6 minus r is going to be 3, times the b part, which is x squared, and I believe there's a 9 on top, right? No, there's actually a 3 on top. There's a 3 on top over here, and the power I'm going to choose is 3. So this is n minus r, and this is r. Let's solve this out. So we have 6 choose 3 times 3 to the power raised to the power 3. That's going to be 540. Because see, this is going to be a 3 on top of there, and then the 3 is going to turn this into a 6. So this thing cancels out with this thing. My answer is going to be having a denominator x to the power 3, and then this part and this part is going to solve to give me 540. Boom. Okay, this is the expansion of the second bracket I need. Now, this thing right over here, I expand it to get this term, and then remember, I have to multiply it with this 4x3 3. So I have to multiply it with 4x3. So 540 times 4x3, that means this thing cancels out with this thing, and then what's 4 times 540? That's going to be 2160. And so the other term that I had, this is the one of the terms that is independent of x, that is independent, and this other term, negative 675, is independent of x. So all I'm going to do is I'm going to do this thing minus 675. That's going to be 1485. This is the term that is going to be independent of x. So we're on question number 5 now. It's a functions question. They say a function f is defined by f of x equals this fraction, and the domain has been given to us as x is less than 1 by 2. State the value of f of -1. Therefore, we can solve this, so we can actually do this on our calculator. And we're going to put in over here 2 times -1 plus 1. And then we have 2 times -1, -1. So this is 1 by 3. That's the value of f -1. Okay, part 2 says the diagram shows the graph of y equals f of x. Sketch the graph of y equals f inverse of x on this diagram. Show any relevant mirror line. How do we do this? How do we sort of sketch the graph of this guy? And this, so this guy has already been sketched out for us. We need to find the inverse graph. Now, try and understand this. The inverse function is basically a reflection of the parent function in the line y equals x. So the line y is equal to x is a straight line that passes through the origin, something like this. Okay, and then we just have to sort of mirror the points that y equals f has to get what y equals f inverse of x will have. So a mirror in the line y equals x means you swap the y and x values. So let me just pick out a few values from this parent function f of x. One of those values is going to be this value, so because it's a really easy value. This is what is this? This is, sorry, this is let me, or you know what, I'll just write it over here. So 0 comma -1, that's one value that's going to get swapped. So it's, when I swap it, it's going to be -1 comma 0. What other value can I sort of go for? So let's go for, I don't see another perfect value over here. Let's go with this one. So this is around I guess x isn't 0, y is 0, clearly. X is -0.5. Okay, that's good enough. Now, I'm just approximating these values because I don't know for sure. So I swap that, it's going to become 0 and -0.5. There I have another value. And let's go with 1 over here. So what is this value going to be? This is this y is almost let's say 0.8, and x is -3. So that's going to become 0.8 and -3. And then let's choose a value over here. So that's going to be x is 0 and y, sorry, not 0, but a little greater than 0. So let's say 0.2. And then y is -3. So it's going to get swapped and become -3 comma 0.2. Okay, so now I can erase this stuff over here that I've drawn, make some room, and then start putting the values down. Okay, so one of those values is, let me just make this line back again. One of those values is -1 comma 0. So x is -1, y is 0, -1 comma 0. That's going to be right over here. -1, 0. Then another point is 0 comma -5. So 0x and -0.5y. That's going to be somewhere over here, right there. And then another point is 0.8 comma -3. So 0.8x, that's going to be somewhere over here, and then -3. -3 is going to be, wait, did I swap this point? I don't think I swapped this point. Yeah, this point I forgot to swap it. Yeah, I probably forgot to swap this point. It's this point, negative 0.8 comma negative 3. It's gonna turn into negative 3 comma 0.8. So negative 3 comma 0.8. Negative 3 comma 0.8. Where's negative 3x? Negative 3x is right here, and comma 0.8. So comma 0.8. 0.8 I believe would be right here. And then I have this point, negative 3 comma 0.2. Huh? Negative 3 comma 0.2. So negative 3 negative 3x comma 0.2. That's going to be somewhere over here. Oh no, actually I think I did it wrong. I think the point was already swapped. I think this I shouldn't have swapped this. This I think I already had swapped this. So 0.8 and negative 3. 0.8x and negative 3. That would be somewhere over here. Because this is 1, right? So 0.8 is going to be just a little bit to the left of it. And then negative 3 would obviously be right here. Yeah, okay, okay. So I can join all of these points. They're going to look something like this. Boom. And there we have it. This looks almost like a good sketch. Okay. So in other words, what's basically happened is this part was mirrored on this side, and this other part. So let me choose a different color. This part, oops, 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 oops. This part, this one, this one, this was mirrored on this side. That's what happened. But okay, moving on to part number 3. Find an expression for f inverse of x and state the domain of the function f inverse. Okay, so what we have to do is, first of all, we have to find the expression f inverse of x. We do know that f of x is equal to 2x plus 1, 2x minus 1, 2x plus 1, 2x minus 1. And what we can sort of do is, instead of writing f of x, we can write y over here. And now we can swap the y and x value. So this becomes x, this becomes 2y plus 1, 2y minus 1. And we basically need to get things in terms of y. So over here, what I did was I swapped x and y. So now we need to make y the subject. The way we can do that is we can do x, we can take this to the other side, multiply it with x. So I get 2xy minus x equals 2y plus 1. And now I can try and gather up my y terms on one side, so I can get 2xy minus 2y equals, and I take this x to the other side, 1 plus x, and then I can factor out a 2y from here to get my y out of this part. That would be 2y, and I get x minus 1 is equal to 1 plus x. And then basically, if I rearrange this equation, it's going to be 2y equals 1 plus x divided by x minus 1. And then I take since the 2 is dividing over here, when I take it to the other side, it's going to multiply. So I'm going to get y equals 2 plus 2x over x minus 1. And there I have it. There's actually one step left. I say that y is equal to f inverse of x, and therefore this becomes f inverse of x is equal to 2 plus 2x over x minus 1. And I have an expression for f inverse of x, but I need to state the domain of f inverse of x. So here's what I do know. The range of the range of what? The range of f of x is the domain of f inverse of x. Therefore, what I'm doing is I'm trying to find the range of f of x, and therefore that's going to be my domain of f inverse of x. So what is the range of f of x? Do I know that? I know the domain. I can use that to find the range. And here's what I can do. If I put in, so there's two things I can do. I can use this graph as well. So if I make this graph less junkier, maybe I can show you guys what I'm trying to show you guys. So this right over here, I'm going to erase all of what I had drawn before. This graph right over here. So this guy right over here. We can sort of try and understand what its range is from this particular graph. See, it's gonna go straight down. It's going down over there. So what does that indicate? That basically means that it's going to go all the way to negative infinity, right? All the way to negative infinity because it's going down. So all of the negative y values, it's going to cover all of them. So it's going to go all the way to negative infinity. What about on the positive side? Is this part, this part. So this part is going to the positive side because it's sort of rising up. Now, we don't know if it's going to continue to rise up or if it's going to plateau at some point. So is it sort of going to go on forever and ever and ever? That's a question that we need to answer. I do think so that yes, that is the case, but I can check that. Basically, how can I check that? We can basically pick up negative values. So over here we had -1, then we had -2, then we have -3 and -4 and so on. If we can pick bigger and bigger values, we can sort of substitute them into this equation and we can find out what the behavior is of this function as we put bigger and bigger negative values of x, or in other words, more and more negative values of x. So if I have the equation 2 times x plus 1 and 2 times x minus 1, what we can sort of do is we can put a value of -100 and we can put a value of -100. So that gives us 0.99 something something. Now, what we're going to do is we're going to put instead of -1, let's put in -10,000 and then let's put in -10,000 over here. What do we get now? So we get -99999. And I think you guys can see the pattern over here. If I add more zeros, if I add 2 more zeros, and then I add 2 more zeros over here, we're going to get 0.999999999, I believe so. See? So what's happening as you pick bigger and bigger or more negative, as you sort of go over here to this side and choose negative values, -5, -10, -100, -10,000, 10 billion, 1 trillion. As you sort of pick up those values, what happens is your y is getting almost closer to 1 because 0.9999999, that's almost close to 1. So this y is basically plateauing. This right here is y equals 1. It's getting closer and closer and closer and closer and closer to 1 as you choose values that are more negative. Makes sense? So basically, the most negative value you can have is negative infinity, and the most positive value you can have is 1. Now, I don't think 1 is achievable. I think you're just going to try and like get closer and closer and closer and closer to 1, but you're never going to actually reach 1. You're going to get super duper close to it. Just like you can never reach infinity, you're not going to be able to reach 1 because you're going to need a really big number to go from 0.999999999 to jump to 1, and that big number is basically you would want your x to go all the way to negative infinity for your y to be equal to 1. So basically, the range of f of x is you're going from, so your range of f of x is basically I could say less than 1. And from less than 1, it can go all the way to negative infinity. So basically, the domain, that means the domain of its inverse function is basically x is less than 1. Okay, perfect. Let's move on to part B. Part B says the function g is defined by g of x equals 3x plus 2 for all values of x, all the way from negative infinity to positive infinity. We have to solve this particular equation. F of x equals g of x uh, with an input of 1 by 4. So what's f of x? It's 2x plus 1. 2x minus 1. What's gf of 1 by 4? We don't know that. Let's find that out. So first of all, this is a function g that has function f of x, and that f of x has 1 by 4. So what we can do is we can find out what this part is, what f of 1 by 4 is, and I believe we've already done that. I believe, didn't we just do that at the start? No, actually we didn't. Okay, never mind. So we got 2 times 1 by 4 plus 1 divided by 2 times 1 by 4 minus 1. So we can basically do that on the calculator. So we could do 1 divided by 4, and then we could do the same thing over here. 1 divided by 4. So we get -3. So this part is -3. And then what we have to do is we basically have to put this -3 to pick it up and put it into this this place, because we know that f of 1 by 4 basically is equal to -3. So now we have g of -3. Now what's g of -3? We know what g of x is. So instead of x, we can put -3. And let's see what this solves out to. So we're going to get 3 times -3 plus 2. That's -7. So all of this is going to be equal to -7. So we can just put -7 over here. And now we can solve this equation out. So let's take this to this side of the equation, the denominator to the other side. So it's going to become -14x positive 7. Let's rearrange things a bit so we can have 2x positive 14x equals 7 minus 1. This is 6. 14 plus 2 is 16x, and then x is basically equal to 6 over 16, which we can simplify to 3 over 8. 3 over 8. So that right there is going to be our answer for this problem. Okay, so we're on to question number 6, which says the diagram shows a metal plate OAB CDEF consisting of sectors of 2 circles, each with center O. The radii of sectors AOB and EOF are r centimeters. So what are sectors AOB? This guy, and EOF, this guy. They both have a radius of r centimeters. The next line says, and the radius of sector COD is 2r, so COD, this big one, the radius is 2r. Okay, angle AOB is equal to angle EOF is equal to theta radians. So they're basically saying that the angle of this and this sector are both this theta radians. So on both sides, they have the same angle of theta. And the next part says, and the angle of COD is 2 theta radians. So this big sector has the angle 2 theta radians. Okay, therefore, the next part says it is given that the perimeter of the plate is 14 centimeters. Perimeter means if you add all of the outer sides, their sum should be equal to 14. And area, the total area of the plate is 10 centimeters squared. So if you add the area of all of this stuff, it should be equal to 10 centimeters squared. Now, let's first digest this. This information, what does this even mean? This information is, they're basically telling you 2 equations. The 2 equations are a perimeter equation and an area equation. That's why they basically tell you this. That's why they give you this piece of information. So let's first find the perimeter. So the perimeter basically means you're going to add this side into this side, 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 into this side. We already know some of the sides. For example, we know this is r centimeters, this is r centimeters. How much is this side and this side going to be? So if you notice, this total side is 2r, this length and this length is r, because they're part of these smaller sectors, and the smaller sectors have a radius of r. Therefore, that means that these 2 sides are going to be equal to 2r minus r, which gives you a value of r over here and a value of r over here. Now, you have to find this arc and this arc, which are the same because both the small sectors are same. Therefore, the formula for this is basically radius times theta. In this case, the radius of the small sector is r, and the angle is theta. So all we have to do is we just know that it's going to be equal to r theta. We don't have to change anything over here. So r theta and r theta over here. Now, some of you may sort of ask, why not just write s over here? If s is the variable for arc length, why not just write s over here? Why write r theta? So see, my answer to that is because everything in this sort of in this sort of diagram is labeled as r and theta. So if I can, why should I sort of introduce a third variable s over here when I can express s in terms of r and theta? Why not just do this instead? Because see, right now I'm dealing with the variable r and I'm dealing with the variable theta. If I write s over here and s over here, I'm introducing another variable. Now I have 3 unknowns. Ideally, when you're solving problems, you want to keep your unknowns as less as possible. And if this can be expressed as theta and r, I should rather do that. Okay, therefore, I write r theta instead of writing s. What side is left? So the arc of the bigger triangle is left now, this arc CD, and that is also going to be found by doing r theta. Now, how much is the radius of the bigger sector? It's 2r. And how much is its angle? It's 2 theta. Therefore, the arc is going to be 4r theta. So this guy is 4r theta. Now see, the perimeter is the sum of all of these sides. So I just have to sort of add all of these sides. The perimeter is equal to r plus r plus r plus r. There are 4 r's in total, r plus r plus r plus r. And then there are the 2 arc lengths, r theta and r theta. And then the big r length, which is 4r theta. Now, instead of writing p, I can write 14 because I know that the value of perimeter is 14 as given to me in the question statement. And then I'm going to get 4r over here. And then I'm going to get 6r theta over here. So this is my equation for perimeter. Now, what about the area? So for the area, I basically have to add the area of this sector into this sector into this sector. And see, since the sector AOB, this guy, is the same as this sector, what I can do is I can find the area of one of these guys, then multiply it with 2. So the area of the smaller sector is going to be 1 by 2, the radius squared, times theta. And since the radius is r and the angle theta is just theta, so this is my formula for the area of one of the small sectors. Since there are two of those sectors, what I can do is I can multiply this with 2, and so this 2 cancels out this 2, and I'm left with r squared theta. So r squared theta is this area as well as this area. Now I have to also add in this area. So what is this one going to be? This is going to be r equals 1 by 2 radius squared. What is the radius? The radius is 2r. What is the angle? The angle is 2 theta. So a is going to be 1 by 2 times 2r squared is going to become 4r squared because they have a square on top, and then 2 theta over here. So this 2 cancels out this 2, and then my answer is going to be 4r squared theta. So the total area is basically r squared theta plus 4r squared theta. And I know that my total area is 10. So this is just going to be 5r squared theta. Okay, so now I have these two equations for perimeter and for area. Let's now read the problem. So we've digested the information. Let's read the problem. It says that r is greater than 3 by 2, or in other words, r has to be greater than 1.5, and theta has to be smaller than 3 by 4, or 0.75. Find the values of r and theta. See, now once you've digested the information, it's so easy to answer this part. How do you find r and theta? You have two equations, and they both have two variables, r and theta. So when you have two equations, two unknowns, you can solve that system simultaneously, and you will get your values for those variables. However, if someone had not written these equations out explicitly, had not digested this particular information, doing this next part would be pretty difficult for them. They would have no idea where to even begin at. Therefore, what I'm going to do now is I'm going to simply solve these equations simultaneously, and what I can sort of do is I can rearrange one of these equations, make one variable the subject, and then substitute that equation into the other equation. So I'm just thinking, which equation should I choose over here? How about I go with this equation, and I make theta the subject. So this is going to be 10 over 5r squared equals theta. 5 times 1 is 5, 5 times 2 is 10. So this equation is going to become theta is equal to 2 over r squared. Now, substituting this into that, I'm going to get 14 equals 4 times r plus 6r, and instead of theta, I'm going to have 2 over r squared. Now, this r is going to cancel out that squared, so I'm going to be left with 14 equals 4r plus, what's 6 times 2? 6 times 2 is 12 over r over here. Okay, so I have a tricky situation right now. I have 14 equals 4r plus 12 over r, and I have to sort of gather the r terms together, if you guys sort of know what I'm trying to say. One way of doing that, one way of sort of gathering the r terms together, is taking the LCM of these two terms. So if I do that, I'm going to get 4r times, so over here the denominator is 1. I'm going to multiply that with r. Over here I have 12 over r, and so I have to multiply r over here as well. So I'm going to get 14 4r squared plus 12 over r. Okay, now the r terms have still not been gathered together. So one thing I can do is I can take this r to the other side. That's going to turn this into 14. R is equal to 4r squared plus 12. And you can see now this looks something much more similar. This is in fact a quadratic equation for r. So if I take this 14r to the other side, I'm going to get 4r squared minus 14r plus 12. This right here is my quadratic equation for r. So let's solve this quadratic equation. I'm going to use the quadratic formula, minus b. So minus b plus minus under root b squared minus 4ac over 2a. So I'm going to get two values for r. Let's try and find out what those values are going to be. First of all, I have minus times minus 14. That's going to be plus 14. Then I'm going to get negative 14 squared minus 4 times 4, and then I have 12. And then in the denominator, 2 times 4. So press equal. One of the values I'm going to get is 2, and the other value I'm going to get that from the negative symbol. So I put a negative symbol over here, and this is 3 by 2. Now, which value do I select? I select this one. Why? Because if you go back, the question told me that r has to be greater than 3 by 2. If I come back over here, this is r is equal to 3 by 2, not r is greater than 3 by 2. So I reject this value. Now, using this value, I'm going to find my value for theta. So using this value, I'm going to find my value for theta. So I can basically take this guy over here, and put it into this equation for theta. Theta is equal to 2 over r squared. Let me just confirm that's the equation. Yep. And then it's going to be theta equals 2 over r squared. So r is 2. I square this. I'm going to get 2 over 4. 2 times 1 is 2. 2 times 2 is 4. And so my answer is 0.5. This right here is my value for theta. And you can actually check this, that theta was supposed to be less than 0.5, 0.75, which basically means theta has to be less than 0.75, and this value is less than 0.75. Therefore, this is my answer for theta, and 2 is my answer for r. Okay, so now we're on to question number 7. It says, by expressing negative 2x squared plus 8x plus 11 in the form this thing, where a, b, and c are positive integers, find the coordinates of the vertex of the graph with the equation this. Now, this is basically the equation that is given over here to us. This is a quadratic equation in its standard form. They want us to convert it into its vertex form. Okay, no problem, we can do that. So how do we convert a quadratic equation into its vertex form? Now, everybody may have a different method. Here's how I do it. So I first write down my equation in its standard form, and remember, the first step should always be to factor out this term. Why? Because I want my coefficient of x squared term to be positive 1. If it's not positive 1, you factor out whatever is next to the x squared. And we're going to factor it out from this entire equation. That's step 1. Have your coefficient of x squared be equal to plus 1. So I factor out a negative 2. I'm now going to be left with x squared. This is going to become negative 4x plus, sorry, this is also going to become a negative. And see, I cannot factor out a negative 2 from 11. So what I'm going to do is I'm just going to divide positive 11 by negative 2. And what that does is that just basically turns this positive sign into a negative sign. So that's how I factor out a negative 2 from positive 11. Now, once you've done that, the second step is look at this b term, not its sign. You don't care about it being positive or negative. You just look at the number, and you divide it by 2. So 4 divided by 2 is going to be 2. Now, this number is going to be hella important. So in the next step, you're going to make some space, x squared minus 4x. You're going to make some space between the b term and the c term. So this was the bx term, this is the c term. You're going to make some space in between. Why is this space important? Because you're going to take this number, you are going to add its square and subtract its square. Now, remember, subtracting its square, this thing is something else, this thing is something else. You want to do this thing, not this thing. These are two different things, okay? What next? So once you have done this, you want to make 2 brackets over here, put a square on top, and then close the square brackets. And then inside of these brackets, you're going to put this x term. From this middle term, you're going to take the sign. From this plusing the square term, you're just going to take this number. And then you're going to solve all of this rest part and put it in here. So this is negative 2 squared, negative 11 by 2. This is going to be negative 19 by 2, negative 19 by 2. So now I'm going to have negative 2 bracket x minus 2 squared minus 19 over 2. And you just multiply this negative 2 inside the bracket now because you've converted it into its vertex form. So it's going to be negative 2x minus 2 squared. This is going to become a positive. The 2 is going to cancel out with this 2, and you're just going to have a 19 over here. So this is now in the form negative ax minus b whole squared plus c. Okay, part B gives us a graph. It says the diagram shows part of the curve with equation y equals minus 2x squared plus 8x plus 11, which is basically this equation, this quadratic that we were dealing with. And the line with equation y equals 8x plus 9. So this right here is the line. It's a straight line. And you can see this right here is the curve. Oh, my bad. Actually, we're not done with part A because we were supposed to find the coordinates of the vertex. So we haven't found the coordinates yet. The way you find the coordinates using the vertex form is you first look at the inside of this bracket, x minus 2, and you put this equal to 0. And then you solve it. So this is going to be x plus 2. this is the x coordinate of your vertex, and then this lonely term over here, this right here is going to be the y coordinate of your vertex. So the coordinates are 2, 19. Those are your coordinates of the vertex. Okay, so now we have a graph as well as a line, and we have to sort of find out the shaded region. So this region. Now there's here two ways you can do this, or rather one way you can do it. I don't know what another way would be, but essentially you look at this graph, okay, and it has one intersection point over here, one intersection point over here. You find the area under this graph, so it's going to be all of this till this coordinate. And then what you're going to do is you're going to take this line and you're going to subtract the area of this line or under this line. So that's the idea. So the formula is, here's the formula that you're going to want to know. So the area of the shaded region is basically going to be equal to the area under curve. So the area under the curve, I'm going to write AUC for area under the curve, minus the area under the line. Okay, so let's first find out these intersection points so that we know when we're going to, because how are we going to find the area of the curve? We're basically going to do some integration, and we're going to have to integrate, and we're going to need bounds. We're going to need this lower point and that upper bound. So for that, we are going to find first the coordinates of this point as well as this point. And then how are we going to find the area of this line? Well, you can do integration, but you can also do something else. So this line, basically this line, if you sort of look at this line between these two intersection points, it basically forms a trapezium. The area under this line forms a trapezium. And you can essentially use the formula of a trapezium, and that is going to be equal to 1/2 times side 1 plus side 2 times height. And what's side 1? This is side 1. This right here is side 2. This right here is going to be your height. And yeah, you can use this formula, or you can use integration for the line as well. That can also work. Personally, I think integrating it is going to be more sort of complicated. It's just easy to use simple geometry. It's completely up to you. But first of all, the important thing is either way, we need to find the intersection points. The way you do that is you basically put this equation equal to this line equation, the curve equation equal to the line equation, to say the y of the curve equation is equal to the y of the line equation. And therefore, you get this equation, negative 2x squared plus 8x plus 11 equals 8x plus 9. Now, this right here is a merged equation, and if you solve this, it's going to give you the intersection points of the curve and the line. So let's get these terms over there on that side. So this is going to be negative 2x squared plus 8x minus 8x plus 11 minus 9 equals 0. Boom, boom, cancels out. You get negative 2x squared. What's plus 11 minus 9? I believe that is 2. 11 minus 9, that is 2. I'm sorry, I just used the calculator for that, but I really don't want to mess up calculation. I don't trust my mental math. Okay, let's solve this for the x now. So taking the 2 to the other side, it becomes a negative 2. These minus signs cancel each other out. Or you can think about it this way. You can make x squared the subject, and so you're going to have minus 2 divided by minus 2. Therefore, what's going to happen is this minus sign gets canceled out with this minus sign. This 2 gets canceled out with this 2. And so you're essentially left with x squared is equal to 1. When you send the square to the other side, it becomes an under root. And so you're going to have x equals positive 1 and x equals negative 1. These are your two intersection points. Now, if you go over here, this right here is going to be x equals negative 1. This over here is going to be x equals positive 1. So now you know your two bounds of integration. They are basically going to be x equals negative 1 as well as x equals positive 1. So now we can find the area under the curve. So the area under the curve, the AUC, is going to be integrating from negative 1 all the way till positive 1. And then what do we have to integrate? We have to integrate the curve, negative 2x squared plus 8x plus 11. Now you can do integration how you've learned it. Of course, everybody learns integration differently. So I'm just going to integrate it. So this term is going to be integrated, this term is going to be integrated, and this term is going to be integrated. I'm going to get 11x, and I'm going to get, this term is going to give me x squared over 2, and the 8 obviously is going to be there. And then this term is going to get me x to the power 3 over 3. and then I'm going to have my negative 2 over here, and then of course the bounds are 1 and negative 1. I can simplify a bit over here, so 2 times 1 is 2, 2 times 4 is 8, so it leaves me with negative 2 over 3 x cubed plus 4x squared plus 11x, and the bounds are 1 and negative 1. Okay, so I think I've done everything correct so far. What I can do now is I can basically write out the equation. So let's first write over here negative 2 divided by 3 times 1 cubed, and then plus 4 times 1 squared plus 11 times 1. All of this is going to solve out to give me 43 over 3. And then I have to minus this other term that I can find out by basically putting a minus over here, putting a minus over here, as well as putting a minus over here. This is going to give me negative 19 over 3. So negative 19 over 3. Okay, so the negatives and negatives become positive. So I have 43 over 3 plus 19 over 3. This is going to be equal to, so 43 divided by 19 plus, 43 divided by 3 plus 19 divided by 3. That is equal to 62 over 3. This is the area under the curve. Now the area under the line is what we have to find out. Here's the problem. I low-key think that integrating it is going to be more easier than sort of finding out, sort of doing it using geometry. Yeah, I think using geometry is going to be a bit difficult because I will first have to use this equation of the line. I have to find the side 2. This I would have to find out how much this y value is, and then to find out this side, I will have to find out what the y value is over here. And to do that, I will have to use this equation. First put in negative 1 over here, then put in positive 1 over here, then find out what my y is going to be. I personally feel like that's going to take longer, so I'm just instead going to use integration. So the area of the line, let's find that out, is going to be the integration of negative 1 to 1 dx. And what am I integrating? I'm integrating the curve 8x plus 9. So this is going to be integrated to, so the bounds are going to be 1 and negative 1, and then this is going to be integrated to 8x squared over 2 plus 9x. 2 times 1 is 2, 2 times 4 is 8. So I get 4x squared plus 9x. The bounds are 1 and negative 1. Let's solve this out. 4 times 1 squared plus 9 times 1. This is equal to 13. And then I have to minus the other term, which is going to be what I get when I put a minus sign over here and I put a minus sign over here. So that's negative 5. The negative turns the negative into a positive. It's going to be 13 plus 5. And 13 plus 5 is going to give me 18. So I have this and this. I have to subtract these two. So 62 over 3 minus 18. That's going to give me 62 over 3 minus 18. The answer, which was 18. So I get 8 over 3. 8 over 3. This right here is going to be my answer, or my area of the shaded region. So we're on question number 8 right now, and this right here is a circle and a coordinate geometry problem. The first part says the equation of a circle is given as x squared plus y squared plus px plus 2y plus q equals 0, where p and q are constants. We have to express the equation in the form that's been given to us right here, where a is to be given in terms of p and r squared is to be given in terms of p and q. So basically what they're saying is this is one form of the circle equation. We have to take it to its other form, or I believe this is the center and the radius form. So the way we do that is we basically do the completing the square method on the x term as well as on the y term, and therefore we find out the equation in this particular form. So we have x squared. Let's first gather up the x squared term. So we have x squared plus px. Then we have y squared plus q. I believe q is a constant. No, sorry, y squared plus 2y. 2y. Q is a constant, so we're going to take it to the other side of the equation. So positive q is going to become negative q. Okay, now we have to complete the square on these things. So how do we do that? We basically pair this part up, and then we pair this part up, and we complete the square on both of these things. So first of all, we take this p, again, the middle term, the b term, bx term, just like we were doing in the previous question. We were completing the square on a quadratic equation. We're just going to complete the square on both of these x terms and y terms. So you take the middle term, the ax squared plus bx plus c. Now this, we don't have a c in this case, but we have a bx term. So you take that middle term and you divide it by 2. So you're going to get p by 2. Now this p by 2 is really important because you are going to add the square of p by 2, add the square of p by 2, and you are going to subtract the square of p by 2. Okay, and then you are going to do the same thing with y. So it's going to be plus y squared plus 2y. You divide 2 by 2, you're going to get 1. That means you're going to add 1 squared and you're going to subtract 1 squared. And so this is going to be equal to negative q. Okay, now you're going to make 2 brackets over here like this, and you're going to make 2 brackets over here like this. Now what goes into these brackets? This x squared term. From this, the x goes in here. From this middle term, the sign goes in here. From this term right over here, from this plus squared term, this p by 2 goes in here. And then we have plus. Right now, we're not going to sort of look at this minus term, and we're not going to look at this minus term. So the minus squared terms, we're going to ignore those for just a second. We're going to put this y, from this y squared, we're going to put this y in here, not the square, just the y. We're going to put the y in here. Then we're going, from the middle term, we're going to put the plus in here. From the plus square term, we're going to put the number in here. And remember, these brackets have a square on top of them. Okay, then what we can do is, remember these negative terms, we are going to take them to the other side of the equation. So we take this guy over here, and we take this guy over here. So we're going to get negative q, and we are going to get negative, so p by 2 squared is going to be p squared over 4. Okay, so this negative sign right over here, when I take it to the other side, it's going to become a positive sign. So let me just fix that. And then this 1 squared, when I take it to the other side, it's going to stay a 1, and this sign is going to become a plus. So I'm going to have a plus 1 over here. So this right over here is the equation. All of this basically is your r squared, represented in terms of p and q, just like the question asked you to do so. And the a term, so you see the plus a term over here, this right here is the plus a term. So a is basically equal to p over 2. Okay, the next part says the line with equation x plus 2y equals 10 is tangent to the circle at point A with coordinates 4, 3. So let's say this right here is the circle, and let's say it has some random point. Let me just pick up some random point, this one. Now this point A has coordinates 4, 3, and we know the equation for this tangent line. What we need to do is we need to find a line that is normal to this. So a line that is normal to this. Now, what's the relationship between a line and its normal? So they both have their gradients. So a line and its normal. So a line and its normal have gradients that are negative reciprocals of each other. So basically what that means is, since they already give us the equation for the tangent line, if I rearrange that, it's x plus 2y equals 10, but it can be rearranged. So I'll get 2y equals 10 plus 10 minus x. So I send the minus to this side, it becomes a minus x. And then what I can do is I can basically send this 2 to the other side. So it's going to be 1 by 2x, and then plus 10 divided by 2 is going to be 5, so it's going to be this thing. Okay, so this right here is the equation. Why is this useful to me? Because this part, see, this is the gradient of the tangent line. The gradient of the tangent line, negative 1 over 2, which means that the gradient of the normal line, we're going to put an n over here for the normal, is going to be a negative reciprocal of this. So first of all, you take a reciprocal of 1 by 2, it's just going to be 2, and then you negative it. So since this was the gradient of the tangent line was negative, when you negative it, it's going to become a positive. So this is the gradient of the normal line. And then since the normal line passes through this point A, it's going to have these coordinates on it, which are 4, 3. Now we know a point that the normal line passes through. We know the slope of the normal line, so we can use the point slope form, which is basically y minus y1 equals mx minus x1, and therefore the equation is going to be, instead of y1 we can put 3, the gradient we know is 2, and then x minus, what's the x1 term? The x1 is 4. So this is going to be y minus 3 equals 2x minus 8, and therefore we can take this 3 to the other side, so it's going to become a plus 3. It's going to be 2x minus 8 plus 3, and so this is simply going to be 2x minus 5. This right here is the equation of your normal line. Now they say find the values of P and Q. How do we find the values of P and Q? So basically try and think about it like this. If this right here is the circle, and this is the center point, and then let's say this is point A, what I have over here is I have a line, or in other words, the radius, that is going to connect the center point to point A. Why is this useful to me? Here's why this is useful to me. The tangent line, so this right here is the tangent line at A, tangent at A. This normal line that they just made me find out, this one, this normal, okay, this orange line. This orange line, so let's say I put a center over here. What this orange line represents is it basically represents the radius as well. So this part of this orange line, this part represents the radius r of the circle. Basically, that's the relationship that we have over here. So I already know the equation of this radius. The equation of this radius is y equals 2x minus 5. That's the equation of the radius. What do I need to find? I need to find point P and I need to find point Q. So how can I do those? How can I find that? See, what is Q? Q is if I go over here, they basically make you, so they say that the radius squared is basically equal to all of this. And then this coordinate is basically, so this is basically going to be the x coordinate of your center point. The way you can find that out is you put x plus p over 2 equal to 0, and then you rearrange the equation so you get x is equal to minus p over 2. This minus p by 2 is what is the x coordinate of the center, x coordinate of the center. So going back over here, negative p over 2 is the x coordinate of the center. What about the y coordinate? What's the y coordinate? So the y coordinate of the center, you can find that from this part. So it's y plus 1, you put that equal to 0, and then you rearrange the equation so you get y minus 1. This y minus 1 is essentially what your y coordinate of the center is. So that's minus 1. Let me just check that again. Minus 1. Okay, therefore, the circle is going to look a bit different. Why? Because A is 4, 3. So here's what the circle is going to look like. Let's say I draw this circle over here. Let's say the points are negative p over 2, comma negative 1. So they're essentially in the fourth quadrant. If I draw coordinate axes over here, so these are the coordinate axes over here. So the center point is going to be in this quadrant, in this third quadrant. Sorry, this is the first quadrant, this is the second one, this is the third one, this is the fourth one. Why? Because both its x and its y coordinates are negative. And the point A, both its coordinates are positive, so it's going to be in this first quadrant. So let's say somewhere over here, 4, 3, somewhere over here. And then what I can do is I can basically join these to look like a circle. Let me just make some room over here. So let me just join these to make some. So I join these to make a circle. And then basically here is where the tangent line is at. Boom. And then the normal, or the radius, is going to be basically this point right over here. This is the normal line, which has the equation y equals 2x minus 5. Okay, so check it out. Here's what I have to do. This right here is the radius. I know the radius equation. I have to find out this p. How can I find this p out? I can basically, since I already know the equation of this radius, I can use this equation to find out my p. What do I mean by that? How can I do that? So see, this is the center point, and this right here is the point A. How can I find the gradient between the center point and point A? So if I want to find the gradient MCA, it's basically going to be y2 minus y1 over x2 minus x1. Guess what? I know what this MCA is. How do I know that? I know the equation of the radius, okay, or basically this line, and I know this line, and I know the gradient of this line. The gradient of this line is basically 2. This is in the form y equals mx plus c. So the gradient is 2. Therefore, I have an equation where MCA is 2, y2 is this coordinate, 3, y1 is this coordinate, so minus 1, x2 is this coordinate, and x1 is this coordinate, minus p over 2. Now I can solve this equation for p, and therefore I will basically find my value for what p is. So let me just solve this equation. So it's going to be 2 equals 3, negative becomes positive, so 3 positive 1 over 4 positive p over 2. Therefore, what's 3 plus 1 going to be? 3 plus 1 is going to be 4. And what's 4 plus p by 2 going to be? That's simply just going to be 4 plus p over 2. Now, I can take this thing to that side, so it becomes 4 times 2 is 8, plus 2 times p by 2 is going to be simply p, because the 2 will cancel out the 2, and this right here is equal to 4. Okay, now I can rearrange the equation, so it's going to be 4, the 8 goes to the other side, it becomes minus 8, and so p is going to be 4 minus 8. What is 4 minus 8? 4 minus 8 is going to be minus 4. So p is basically equal to minus 4. Now let me just check if I go back over here. Okay, so they don't say p has to be a positive constant, which means p can be negative. Okay, I was just checking that. I was worried if my p is going to be a positive constant or a negative one. So I've now found the value of p. How do I find the value of q? So check this out. The radius, so the radius squared, here's what the radius squared is equal to. The radius squared is equal to negative q, positive p squared over 4 plus 1. Positive p squared over 4 plus 1. Here's how you can find how much q is equal to. First of all, p is equal to negative 4, so instead of writing p squared, I can write negative 4 squared, and negative 4 times negative 4 is positive 16. So I have 16 over 4, and I can simplify this. 16 over 4 is simply equal to 4. So I simply have 4 over here, and 4 plus 1 is simply equal to 5. So I can erase this and write 5 over here. So my r squared is 5 minus q. Now I have to find q somehow. If I somehow figure out what this r squared is equal to, I can then solve this equation for q. So how can I figure out what r squared is going to be? Here's how I can figure out. From point C to point A, I can find out how much distance there is, and that distance is basically going to be the value of the radius. Because what is radius? Radius is just a distance. It's a distance between 2 points. Therefore, if I can find out the value of the radius, I can put that in here. And how do I find the value of the radius? Well, it's really simple. Again, I just have to find the distance between point A and point C. So the distance formula is basically equal to under root, or since in this case the distance is the radius, so I'm just going to write the radius over here. The radius is equal to change in x squared plus change in y squared. What I can sort of do is I can sort of do change in x, which is going to be the x coordinate of A minus the x coordinate of C. So what is C? C is negative p over 2. What is p? P is negative 4. So negative times negative is going to be positive 4 over 2. And then 2 times 1 is 2. 2 times 2 is 4. So I'm going to have 2 over here as the x coordinate of C. And then for y, I'm going to have the y coordinate of A minus the y coordinate of C. The y coordinate of C is basically negative 1. Negative 1. Okay, so this is what I have over here. Therefore, I can solve this in my calculator. So and I believe they also have a square on top of. So square on this bracket and a square on this bracket. So I can do under root 4 minus 2 is 2, so this is 2 squared. Or you know what, we can ignore the under root for now. So it's 2 squared plus 3 minus minus 1. Minus minus becomes plus. 3 plus 1 is 4, so I have 4 squared. This is going to give me 20. So radius is equal to under root 20. What I can do with this is I can basically put under root 20 in place of r, and so it's going to be under root 20 squared is equal to 5 minus q. The square and square root cancel out, so I get 20 equals 5 minus q. I can rearrange the equation, so if I take q to this side, take 20 to this side, my q is going to be 5 minus 20. So 5 minus 20 is going to be negative 15, and that right there is going to be your value for q. Okay, let's begin with our question number 9. It gives us the equation of a curve y equals 1 by 2 k squared x squared minus 2kx plus 2, and the equation of a line, which is y equals kx plus p. Both of these equations have k, and the equation of the line has a variable p. They say where k and p are constants, so that means that they are just some random numbers, and then they give us a value for k that can only be between 0 and positive 1. Part A says, it is given that one of the points of intersection of the curve and the line has coordinates 5 by 2, 1 by 2. Find the values of k and p and find the coordinates of the other intersection point. Okay, so this may seem a bit tricky because right now we have no idea about how we're going to find this intersection point, how we're going to find this k and p, all of that stuff. So here's a good starting point. The reason they give you these coordinates is so you can plug them into this equation and this equation. Now, why would they do that? See, you're trying to find k and p. Now, look at this curve equation. How many variables does it have? It has the variable y, x, and some k that we don't know the value of. Now, if you plug in this point in this curve, you can basically have a value for y, a value for x, and then you can solve this equation for k and get a value for k. Now, how can you sort of put this point in this equation? Why is that allowed? The reason is because, see, they tell you that the intersection points of the curve and line are these points. Therefore, that means the curve, whatever it looks like, let's say this, and the line, let's say this, and I know the line and the curve will have two intersection points because they literally say find the other intersection point. So once this one, one's going to be this one, that means they intersect at two positions. Therefore, what it means is that these 2 points lie both on the line as well as on the curve. So if let's say this is the point that you have the coordinates of, you can therefore put this point in here and find out the value for k. Now, some of you may be like, well, okay, why not put these coordinates in this line equation and find k and find p? Well, because see, if you put these points in this line equation, how many variables or unknowns do you have in this equation? Y is unknown, k is unknown, x is unknown, and p is unknown. So if you put in these coordinates, you can find out your y. You can find out you will have your y unknown. Y is going to be this 1 by 2, and x is going to be this 5 by 2. But you're going to have two unknowns. With two unknowns, you cannot solve the equation. Therefore, we are going with the curve equation because that's the one we can solve. Now, I'm going to write these coordinates in decimals as well. So 5 by 2 is 2.5, and 1 by 2 is 0.5. Therefore, let's chuck these coordinates into the curve equation. The curve equation is y equals 1 by 2. Sorry, instead of y, I have to put in the value for y. Let me just do that. So what is y? Y is going to be this 1 by 2, or this 0.5, and we can chuck it in the place of y. And then we have 1 by 2 k squared x. So what I'm going to do is, instead of 1 by 2, I'm putting in 1 by 2, 0.5. And then instead of x squared, I'm going to put in the value of x, which is 2.5. And this is going to be 25 over 8, which is 3.125. So 3.125 k squared minus 2kx. So what's 2 times x going to be? X is 2.5. So it's going to be 5k plus 2. Let's solve out this quadratic equation, but before that, let's sort of bring this part onto the right-hand side. So we're going to have 0 equals 3.125 k squared minus 5k, and then plus 2 minus 0.2 minus 0.5. That is going to give us 1.5. So now we have a quadratic equation for k. If you solve this quadratic equation out, we are going to find the values of k. Therefore, we can use the quadratic formula, which is minus times minus b, and then plus under root b squared minus 4 times a times c. And then in the denominator, we have 2 times a. So this is equal to 1 by 2. And then the other value we are going to get is when we change this sign with the square root into a negative sign. So boom, negative equals, this is 0.4. Now, we are not going to go with both of these values. In fact, we're only going to go with this one. The reason is because if you notice over here, there is a condition. K can only have values that are between 0 and positive 1. Therefore, 1 by 2 is out of that range. So we're going to reject 1 by 2. Okay, so that's k. Now we know what k is, and we can therefore use this coordinate. And therefore, if we chuck all of these values in this equation, we're going to know y, k, x, and so we can find out what p is going to be. So let's do that. Therefore, we have y as 0.5, k as 0.4, x as 2.5, and then we have plus p. So we have plus p. So this is going to be 0.5 equals 0.4 times 2.5. So that's 1 plus p. Now we rearrange this equation, send this 1 to the other side. It's going to become a minus 1. So 0.5 minus 1 is going to be minus 0.5 equals p. This right over here is your value for p. So now we have the value for k, and we have the value for p. How do we find the other point of intersection? Well, to do that, you basically need the merged equation. What does a merged equation do? So you have a curve, right? You have a curve and you have a line, both intersecting each other. Now again, I don't know what the curve looks like. The curve could look something like this. It could look anything. It could look, it could be an upward facing parabola, downward, whatever. I don't care about that right now. I'm just explaining to you guys what I'm about to do. So basically, I have a parabola and I have a line. They're intersecting each other at 2 points. I have an equation for this guy, and I have an equation for this guy. If I basically add both of these equations, meaning not add them, but basically if I substitute both of those equations into each other, or in other words, if I solve them simultaneously, I'm going to get, if I solve them simultaneously, I'm going to get the merged equation. And the merged equation is basically going to spit out these two coordinates for me. So that's my plan. Therefore, what I'm going to do is I'm first going to chuck in my value of k into this equation, and chuck in my value of p into this equation, and find out what these equations are. So for the curve, the equation is going to be y equals, it's 1 by 2 k squared, right? So it's going to be 1 by 2 times k squared, k is 0.4. So this right here is going to be 0.08, 0.08 x squared, and then I have minus 2k. So 2 times 0.4, this is going to be minus 0.8, minus 0.8, and then I have plus 2. So there's an x over here, and then I have plus 2. This is going to be the equation for the curve. And then for the line, I'm going to have the equation y equals k. So k is 0.4. I can just write 0.4x. And then I have plus p, but I know that p has a value of negative 0.5. So instead of plus p, it's going to be negative 0.5. And now I can merge both of these equations, or in other words, I can solve them simultaneously. So I can say that the curve equation yc is equal to the line equation yl, and therefore instead of yc, I can substitute this. Instead of yl, I can substitute this. So I get 0.08 x squared minus 0.8x plus 2 equals 0.4x minus 0.5. Now I can arrange all of the terms on one side of the equation, so taking this to the other side, as well as taking this to the other side. So I get 0.08x squared, and then I'm going to get minus 0.8x, and the 0.4x goes to the left-hand side, so it's going to become a minus 0.4x, and they're going to solve out to give me minus 1.2x. Minus 1.2x, and then I'm going to have plus 5, plus 2, plus 0.5, so that's going to be plus 2.5. All of this is equal to 0. Now I can solve this quadratic equation, so that's going to be minus b is 1.2, plus under root b squared, negative 1.2 squared, minus 4 times a, 0.08, and then c, and then divided by 2 times a, 2 times 0.08. So this is going to give me 12.5. And the other coordinate I'm going to get from this equation is actually going to be this one, 5 by 2. Because one of the coordinates of intersection point was already given to me, and one of them was the one I had to find. So if I go over here and I turn this into a negative, I should get a 5 by 2. And there you have it. So this is the other coordinate. Now we're not interested in this one because this one was already given to us. So this was the one we had to find. So we know that the other coordinate has an x value of 12.5. Now what's going to be the y value? We can find that out by going into either the curve equation or the line equation, and you can put the x coordinate we just found into either of these equations, and it's going to give you the y value. I'm going to go with the line equation, so I'm going to do y equals 0.4 times 12.5 is my x value minus 0.5. So this is going to be 0.4 times 12.5 minus 0.5. So this right here is going to be 4.5. Y equals 4.5. Therefore, my coordinates are 12.5, comma 4.5. This right over here is my are my coordinates. Okay, part B says it is given instead that the line and the curve do not intersect. This is an important statement. What does this mean? When basically two things do not intersect, that means their merged equation has a discriminant is less than 0 or has a negative value. Or in other words, the discriminant is basically equal to b squared minus 4ac, and so the b squared minus 4ac of the merged equation is less than 0 or it's negative. So again, what does the merged equation do? The merged equation is the equation that has the curve and it has the line. Therefore, when the discriminant is less than 0, that basically means that this line is never going to intersect with that curve. It basically means that we have this particular situation. If it's equal to 0, then that means, so this means that the discriminant is less than 0. When the discriminant is equal to 0, that means it touches the line and the curve touch at just one particular point. When it's greater than 0, that means they intersect at two particular points, okay? Therefore, what does this mean? This means that the discriminant b squared minus 4ac is less than 0. Now, we have to find the set of possible values of p. For this particular instant, when they do not intersect, we have to find out what the values of p are going to be in that particular case. Therefore, what we're going to do is we're going to get the merged equation. So going back over here, we have the curve equation and we have the line equation, and we're going to combine both of these. We're going to get a merged equation, and then within that merged equation, we're going to set the condition that the discriminant is less than 0, which means they do not intersect. And for that particular situation, we're then going to find out the values for p. Now, we are also not going to use this particular value of k, because we got this value when intersection was indeed happening. Now intersection is not happening, because see, if you just use the equation with this particular value of k, then just realize this was the value of k, so this value was the value I found when I had these intersection point coordinates. So these were intersection point coordinates, these were intersection coordinates, and I plugged these intersection coordinates into my equation, and I solved the equation to get this value of k. However, when they do not intersect with each other, of course they're not going to have these coordinates, and if they don't have these coordinates, my value of k cannot be 0.4. Therefore, what I just have is I have the starting point where my curve equation is simply going to be y equals 1 by 2 k squared x squared minus 2kx plus 2, and my line equation is going to be kx plus p. Let me just check if these equations are correct. So plus p and minus 2kx plus 2. Okay, so they're correct. Now we have to create their merged equation again. So how we can do that is we say yc is equal to yl, and then instead of yc we put this curve equation. Instead of yl we put that line equation. So we get 1 by 2 k squared x squared minus 2kx plus 2 equals kx plus p. So let's move everything to one side of the equation. So if I move these things to that side, I'm going to get 1 by 2 k squared x squared minus 2kx minus kx plus 2 plus, sorry, not plus 2 plus p, but and p is going to become minus, so it's going to be plus 2 minus p is equal to 0. Now notice what I did. This term had an x, this term had an x. I grouped them together. This was a constant number, this was a constant number. I grouped these constant numbers together. Now I did them for a particular reason. Why? Because I'm going to use this idea to convert this equation into its standard form. So remember, I'm trying to find the discriminant, right? b squared minus 4ac. Now that would be way easier to figure out what b, a, and c are if I have the equation in ax squared plus bx plus c form. So what I'm about to do is I'm about to turn my equation into the standard form, and you're going to just notice how I'll do that. It's going to be 1 by 2 k squared x squared minus, or rather plus minus 2k minus k, and I factor out an x. So this guy has an x, this guy has an x. I factor out their x terms. Okay, and then this is going to be my constant. So now this equation is ax squared, all of this is a, plus bx, all of this is b, and then plus c, so all of this is c. And now I can sort of figure out the discriminant really easily. B squared minus 4ac is less than 0. So what is b squared? B is negative 2k negative k squared minus 4 times a. A is 0.5 k squared. And then what is c? C is 2 minus p. And all of this is less than 0. So that's the discriminant being less than 0. Okay, so now let's simplify this stuff. I don't think I'm going to have space over here. Okay, so we can simplify this, all of this first. So this is going to be 4 times 0.5. 4 times 0.5 is going to be 2. Let me just write it over here. So this is 4 times 0.5 is going to be 2k squared, and then 2k squared times 2 is, and then remember there's this minus sign as well. So minus 2k squared times 2 is going to be minus 4k squared, and then minus 2k squared times minus p is going to be plus 2k squared p. I hope I did that correctly. So 2 times 2 is 4, then k squared, and then the minus becomes plus, and then 2k squared plus p. Okay, I did that correctly. Now let's solve out this part. Now I don't know how to solve this identity because it's not a plus b whole squared, and it's also not a minus b whole squared. So what I'm going to do is I'm going to try and convert it into this guy. And the way I do that is basically it's negative 2k negative k squared. What I can do is I can basically factor out the negative. So if I factor out the negative from inside the bracket, I'm basically just going to have this thing, and this entire thing has a square on top of it. So then it's going to be negative 1 squared 2k plus k squared. Negative 1 squared is just going to be positive 1, so I can neglect that because anything times positive 1 is just that thing. So it's going to be 1 times 2k plus k squared. Now, this term, this bracket now becomes a plus b whole squared. So a plus b whole squared is basically a squared. So that's going to be 4k squared plus 2ab. So 2ab is going to be 4k squared because 2 times 2 is 4. So I'm going to get 4k times another k, so it's going to be 4k squared, and then plus b squared. So b squared is just going to be k squared. So I'm going to get 4k squared plus 4k squared plus k squared. Now here's what's going to happen. This is negative 4k squared. This thing can cancel out this thing, and then 4k squared plus k squared is going to give me 5k squared plus 2k squared p is less than 0. So what I can do is I can basically send the 5k squared to the other side. So if I do that, I'm going to get 2k squared p less than 0. Oh, sorry, is less than negative 5k, is less than negative 5k squared. So I take this 5k squared, send it to the other side, and now what I can do is I can basically take this negative 2k squared, take it to the other side. It's multiplying over here, so when I put it over there, it's going to divide. So I'm going to get p is less than negative 5k squared is equal to 2k squared. Now the k's cancel each other out, so this k cancels this k, and I'm going to be left with p is less than negative 5 over 2. We're on to the last problem of this paper. Question 10 says a function with domain x is greater than 0 is such that its f prime of x, or its derivative, is given to us by the equation h bracket x. And I'm not going to read this equation. It's a really long equation, but they're basically telling us that you can find the derivative of the function using this particular equation. The next line says it is given that the curve with the equation y equals f of x. Okay, so basically this is the curve, and this is its derivative. So they're saying that the curve passes through, so let's say whatever this curve is going to be like, okay, let's say whatever this weird shaped curve is going to be like, it passes through a point which is 1, 0. X is 1, y is 0. Part A says, find the equation of the normal to the curve at this point. See, same point. So what they're really asking us to do is they're really saying to find a normal. So this right here is the point. You want to find the normal to this. How do you find the normal to such a point? So basically this line is going to have this point is going to have a tangent line, right? That touches it at just this particular instant. And that tangent line is going to have a line that is 90 degrees to it. That 90 degrees line is basically the normal line at this particular point 1, 0. And we need to find the equation of that normal line. So to find the equation of a normal line, you generally need two things. You need a point and a slope. A point and a slope. Luckily, we do have a point. The point is 1, 0, because of course the normal is going to pass through that point, and then we just need a slope. So how can we find the slope? Well, we can find the slope of the tangent line. We can find the slope of this tangent line because we have the derivative equation for the curve. So what does the derivative equation do? The derivative equation basically tells you the slope of the tangent line of the curve at any particular point. And then what we can do is once we find that slope, we know that it's going to be the negative reciprocal of this normal slope, right? That's the relationship between a line and its normal, is that their slopes are negative reciprocals of each other. Therefore, this is what I'm going to do. So I have, what do I have? I have my slope equation, f prime, and I'm going to find my the gradient of the tangent line at this point 1, 0. So the x coordinate is 1, therefore we are going to get 8 times 2x, so 2 times x is just going to be 2 because x is 1, so 2 times 1 is 2, minus 3, 1 by 2 minus 10, and then it's x raised to the power 2 by 3, but I know x is 1. 1 raised to 2 by 3 is just going to be 1. So we have this particular thing. Let's solve it out. So we got 8 times negative 1 because 2 minus 3 is negative 1 raised to the power 1 by 2, 1 divided by 2 minus 10. Wait, did I do something wrong? This should not have happened. The equation of the normal. Interesting. So I'm getting a negative value, and that's probably due to this guy. What did we do wrong over here? I know what I did wrong. So this is actually 1 by 3, not 1 by 2. Okay, that's what we did wrong. Okay, so going back, this is 1 divided by 3. So it's negative 18. So m is negative 18. Now this is the slope of the tangent line at this point. We want to find the slope of the normal line. So that's going to be the negative, which means it's the negative of this negative 18 is just going to be positive 18. And then the negative reciprocal. So the reciprocal of positive 18 is going to be 1 over 18. This is the slope of the normal line at the point we have. We have the coordinates of the point 1 comma 0. Therefore, we're going to use y minus y1 equals m x minus x1, therefore we're going to have y minus 0, because y1 is 0, m is 1 over 18, x is x, and x1 is 1. So we're going to get y equals 1 over 18x minus 1 over 18. This right over here is going to be the equation of our normal line at this particular point. Part B says, find f of x. So we have the derivative equation of f of x. If we integrate the derivative equation, we find the equation of the curve. Therefore, if we integrate, so we have this guy, f prime of x, is equal to 8 times 2x minus 3 raised to the power 1 by 3 minus 10 x raised to the power 2 by 3. If we integrate both sides, so this guy, integrate this guy, and integrate this guy, we're going to get f of x over here, and we are going to integrate this particular part now. So one thing I can do is you guys can do integration the way you've learned integration. I'm going to do integration the way I've learned it. So the way I've learned it, I'm first going to simplify these two things. So I'm basically have a minus sign, which means I can split the integral at these two particular positions. So one integral that I'm going to get is integral 8 2x minus 3 raised to the power 1 by 3 dx, and then I'm going to have minus integral 10x 2 by 3 dx. So over here, I can take this 10 outside of the integral because it's a constant, and so I just have to integrate x raised to the power 2 by 3. So what's 2 by 3? 2 by 3 is basically equal to 0.666. I just have to add 1 into this because when you're integrating, you add 1 to the power, and I'm going to get 5 by 3. So it's going to be, and then I'm going to divide it by 5 by 3 as well. So it's going to be negative 10x to the power 5 by 3 over 5 by 3. And so what's 10 divided by 5 by 3? 10 divided by 5 by 3, that's going to be 6. So I can actually simplify all of this to 6x raised to the power 5 by 3. Okay, and then I'm also going to have to integrate this first integral. I can pop this 8 outside the integral because it's a constant. Now I can use u substitution over here. So I can call this entire thing u, and so u is going to be 2x minus 3, and du by dx is going to be equal to 2x, because if you integrate 3 with respect to x, it's going to be 0. If you integrate 2x with respect to, oops, my bad, this is going to be 2. If you differentiate, my bad, if you differentiate 2x with respect to x, it's just going to be 2. Now, let's make dx the subject. If I make dx the subject, so bring dx over here, take 2 to the other side, so I'm going to get du over 2, okay? Or you can also write this as dx is equal to du multiplied by 1 by 2. So now I know what dx is. Therefore, I can say 8 integral. I'm calling all of this bracket u, so it's going to be u raised to the power 1 by 2. And I know what dx is in terms of u. I just found that out over here. So instead of dx, I can write 1 by 2 times du. Okay, now this thing is a constant, so I can pop it outside of the integral. So it's going to be 8 by 2. And then I can basically keep on integrating this. This says f of x equals 8 divided by 2 is going to give me 4. U has a power of 1 by 2. We could do 0.5 plus 1. that's going to give us a power of 3 by 2. So we're going to have an answer of u raised to the power 3 by 2 divided by 3 by 2 minus 6x raised to the power 5 over 3. And what we can do over here is we can basically find out what 4 divided by 3 by 2 is going to be. So that's going to be 8 by 3. And so we're going to have 8 by 3. Instead of writing u, we can now bring back what u was, and we know that over here at this position. So we said that u is going to be 2x minus 3. So we can basically bring all of that back. So we can write 2x minus 3, and its power is 3 by 2 minus 6x raised to the power 5 by 3. And of course, we're done integrating, so don't forget a plus c at the end. Okay, and then we can find the plus c because we are given one coordinate, which is 1, 0, 1, 0. So we can plug that coordinate in here, 1, 0 in here. So f is going to be 0, f of x is going to be 0, and then it's going to be 8 by 3 times 2 times 1 is going to be 2. 2 minus 3 is going to be minus 1. So you're going to have minus 1 over here, 3 by 2 minus 6 times x, x is 1, 1 raised to the power 5 by 3 is just going to be 1, so you're just going to have 6 over here, and you're going to have plus c over here. So let's solve this part out. We're going to have 8 divided by 3 times negative 1 raised to the power 2 divided by 3. Oh, sorry, it's 3 divided by 2. 3 divided by 2, and then we're going to have minus 6. So this is, oh, it's giving me a math error. Did I do something wrong? 3 by 2. I think I may have done something wrong. What did we do wrong over here? Oh, okay, I know what I did wrong. So this was 1 by 3. I copied it wrong. I wrote it 1 by 2. This is going to be 1 by 3. Okay, so this over here is also going to be 1 by 3, which means that, so 1 by 3. I'll have to do it all over again. 1 by 3 plus 1. Okay, 1 by 3 plus 1. That's going to be 4 by 3. So this becomes 4 by 3. This also becomes 4 by 3. And then this becomes 4 by 3. And this constant is going to change. This constant is going to become something else. So 4 divided by 4 by 3, that gives us 3. So this is going to be, this right here is going to be 3. And this right here is going to be 3. Yeah, okay. So then that means that we're going to have 4 by 3 over here. So we can do this again. So it's going to be 3 times negative 1 raised to the power 4 divided by 3 minus 6. Now that is equal to negative 3. So 0 equals negative 3 plus c. And then if we rearrange it, send 3 to the other side, it's going to become plus 3. And so our answer is going to be f of x is equal to, what's the equation? This right over here is the equation. So it's 3 times 2x minus 3 raised to the power 4 by 3 minus 6x raised to the power 5 over 3, and then plus 3. This right over here is going to be the equation of the curve. Okay, part C says, it is given that f inverse of x is equal to 0. So what does this mean? This means the derivative is equal to 0. When is the derivative equal to 0? The derivative is equal to 0 at a turning point, at a stationary point, at a maximum or a minimum. So they say that you can basically write the derivative as this equation. Now, why did they tell you that? Because initially you had I believe you had it in its this particular form. So this right over here. And they're basically saying that instead of writing the derivative in this equation, you can write the derivative in this equation over here. And so part C says, determine, making your reasoning clear, whether f is an increasing function, a decreasing function, or neither. So how do we use this idea, this information that they've given us to answer the question? Well, see, if you have a, how do you figure out if you have an increasing function, a decreasing, or neither? So I guess neither would mean that it's both an increasing function or a decreasing function. So an increasing function as well as a decreasing function may look like, let's say, a parabola. So a parabola has one turning point, let's say right over here. So this turning point is where the slope is horizontal, it's 0. On this side, you can see the slope is decreasing. Why? Because if you draw tangent lines over here, they're going to be downward facing. Over here on this side, the slope is increasing, because if you draw tangent lines, they're going to be upward facing, or upward sloping. Therefore, the turning point is where the slope changes. So over here, this is actually a both function. It's an increasing as well as a decreasing function. However, if you have, let's say, a particular line, a line does not have a turning point. So there are no turning points. And therefore, since it doesn't have a turning point, the slope doesn't get to change. It's just a continuous sort of this upward, or sort of this positive sloping or sort of this upward going line. It's an increasing function. It's never going to decrease. It's never going to change its slope. And until it changes its slope, it's not going to be increasing or decreasing. Let's look at another example. Let's say you have a curve that looks something like this. So an exponential curve, for example. So an exponential curve will do something like this. Now you may not know what an exponential curve is. You don't have to know it. Just imagine there's a curve that looks something like this. So this curve is also a purely increasing curve. Why? Because it doesn't have a turning point. If you draw a tangent line over here, it's less upward opening, or it's less upward sloping. If you draw a tangent line over here, realize it's more upward sloping. So the slope increases, and the y values over here, they're also going to increase. So whenever you have just increasing y values, that means your function is increasing. Okay, and so let's say you have a function that is something like this. So a cubic function. Let's say it's something like this. Now this has two turning points. So whenever there are turning points, what happens is that the behavior of the function changes. Up till this point, you can see it's increasing. All the y values are going up, as well as if you draw a tangent line, you will see that the tangent line is also upward sloping. Then comes the turning point. That's where the slope is horizontal, and then this part is where the function is decreasing, and then another slope, and then another turning point, and the function starts increasing again. So ideally, what turning points are doing is they decide whether your function is going to increase, decrease, or it's going to change its behavior. When you don't have a turning point, like in these two particular situations, your curve does not change its behavior. So therefore, what we're really trying to look at is we're trying to look at if we have a increasing function, a decreasing function, and the way we can figure that out is we can basically try and find that turning point, which if it exists means the curve changes its behavior. If it does not exist, that means the curve does not change its behavior. It's either going to be purely increasing or it's going to be purely decreasing. So therefore, the way we can find the turning point is we already have the equation right over here. We are going to put this equation equal to 0, and we're going to solve out this quadratic equation. So we're going to have minus b plus under root b squared minus 4 times a times c, and divided by 2a. So we don't get a value, and then the reason for that is, if I change this to a negative sign, yeah, I believe that's still not going to do anything. Okay, so we don't get a value. Why do we not get a value? If you realize, if I write the equation, if you look at this part, so all of this under the square root. So this is basically under root negative 128. Hold on, if I just solve this part out, so this is negative 128 squared minus 4 times a times c. The reason we're not getting an answer is because if you solve this part out, negative 128 times negative 128 minus 4 times 125 times 192, you're going to realize that you end up getting a negative answer. So you get negative 79616. Negative 79616. What does that mean? That basically means that you cannot solve this because you cannot square root a negative number, and therefore the roots do not exist, or the solution does not exist. Or in this particular situation, what does this equation tells us? It tells us the maximum point. So since we're not getting an answer due to this, what we can deduce is there is no turning point. No turning point, no maxima, no minima, no stationary point, no turning point. What does that mean? We just talked about it. It means our function will not change its behavior. So it's either going to be positive or it's either going to be negative. Or in other words, it's either going to be increasing or it's going to be decreasing, since there are no turning points. Now, how do we figure out whether it's increasing or decreasing, or maybe even constant, because there are constant functions as well. So for example, if you just have a straight line, this is the x-axis, this is the y, and let's say you just have a straight line, y equals 1. That has a slope of 0. And it's also going to be a constant function. It's not going to change its value. So how do we figure out whether it's this guy, or it's this guy? Because we know it's one of those things. It's not two at the same time, because in order for it to be two at the same time, it needs to have turning points, which it does not have. So it doesn't change its behavior. Now we just need to find out what its behavior is. And the way we can do that is we can basically use this equation that we have, or you can use the original derivative equation that you have. It doesn't matter which one you use. I'm just going to use this one. So this f prime of x is equal to, or you know what, you just use the original one if you want to. So it's 8 2x minus 3, 8 2x minus 3 raised to the power 1 by 3, and I believe it's minus 10 raised to the power 2 by, minus 10x raised to the power 2 by 3. Minus 10x raised to the power 2 by 3. And then the domain the domain that you were allowed was x is greater than 0. Let's check that. That's the domain allowed to us. Yep, that is the domain allowed to us. Okay, so basically, let's see what the slope is going to be for values of x that are going to be greater than 0. So we have the curve 8 times 2x. Now x could be anything that is greater than 0, so I'm just going to put a random number 10 in here, -3, and then I have 1 divided by 3 over here, and then I have -10 times 10 raised to the power 2 divided by 3. So this is a negative answer, so we get a negative answer over here. What does this negative mean? A negative derivative means the slope is negative. The slope is decreasing. Okay, so it puts us in this second category. And since I know there are no turning points, I know the slope is never going to change, because in order for a curve to change its behavior, we just talked about this, it needs to have turning points. It changes its behavior at those turning points. Since we have no turning points in our example, it's always going to be positive. It's never going to change its behavior, and therefore the curve is going to be decreasing forever and ever and ever. So this right here is our final answer.